This presentation is about the area between curves. Lesson objectives. To be able to find the area between curves. Right, so in this case we've got a curve y equals f of x, which is at the top, and a curve y equals g of x, which is at the bottom. We want to find the area between the curves between x equals a and x equals b. To find this, we do the integral between a and b of f of x dx, the integral of the top curve, minus the integral between a and b of g of x dx, the bottom curve. Now this works even if the region goes below the x-axis. In this case, we've denoted regions by capital A, capital B, capital C, and capital D. F of x is the top curve, g of x is the bottom curve. So the integral between a and b of f(x) dx is equal to minus c, because that's below the x-axis, plus a, because that's above the x-axis, minus d, because that's below the x-axis. The integral between a and b of g of x dx is equal to minus c, because that's below the x-axis, minus b, because that's below the x-axis, minus d, because that's below the x-axis. Now if we do the subtraction of those two integrals, the integral of the top, which is f of x, minus the integral of the bottom, which is g of x, we get minus c plus a minus b, minus c minus b minus d, from the brackets, minus c plus a minus b, plus c plus b plus d, c's and d's cancel, and we're left with a plus b, which is the area, the shaded region, the area between the two curves. So it still works even if the region goes below the x-axis. So in this example, we want to find the area between y equals x times 4 minus x and y equals x. So a little sketch will be useful in order for us to know which is the top curve and which is the bottom curve. Draw some axes. Now y equals x is just simply the diagonal line going through the origin. And then the other curve is a quadratic. It's already factorised. X times 4 minus x. So the x means that it crosses the x-axis at 0. 4 minus x means it crosses the x-axis at 4, because 4 minus 4 is equal to 0. If we multiplied it out, we would get 4x minus x squared, so we've got an M-shaped quadratic. We want the area in between the two curves, so that's the shaded region. The next problem we have is that we don't actually know where the two curves cross in order to do our integration, to get our limits for our integration. Now it crosses at x equals 3. To show this, we've got y equals x, and y equals x times 4 minus x. We do simultaneous equations, find where they cross. They're both equal to y, so they're both equal to each other. So x equals x times 4 minus x. Multiplying out, x equals 4x minus x squared. Collecting terms, move everything over to the left hand side, add x squared to both sides. Take 4x from both sides, we get x squared minus 3x is equal to 0. Factorising, x is common to both terms, so we can take x out. X times x minus 3 is equal to 0. So it crosses at x equals 0, which we already had, as they cross, both the curves cross through the origin, and x equals 3, which is the curve where the two curves cross again. So our limit is 0 and 3. The quadratic was the top curve, and the straight line was the bottom curve, so we're doing the integral between 0 and 3 of x times 4 minus x dx minus the integral between 0 and 3 of x dx. Multiplying out the quadratic, so we can integrate. X times 4 is 4x, x times x is x squared. Integrating term by term, 4x, increase the power by 1 gives 4x squared, divide by the new power, divide by 2. X squared, increase the power by 1, becomes x cubed, divide by the new power, divide by 3. Minus the integral between x squared minus the integral between 0 and 3 of x dx, increase the power by 1, x to the 1 plus 1 is x squared, divide by new power, divide by 2, integral between 3 and 0. Simplifying, 4 over 2 is 2, so the first expression is 2x squared, none of the other expressions simplify. Sticking our limits in for the first one and subtracting, 2 times 3 squared minus 3 cubed over 3, when we stick 3 in, take away, stick 0 in, 2 times 0 squared minus 0 cubed over 3, take away, we need to stick 3 into x squared over 2, so we get 3 squared over 2, minus, stick 0 in for x, so we get 0 squared over 2. Sticking all that into a calculator, we get the area is 9 over 2. This concludes this presentation.